And we're live. Welcome to Set Impact, where we discuss how emerging technology is changing sectors, society, and the world at large. For a brief period, for around about 6 weeks, I'll be speaking to founders and also employees of some of the most hardest and most interesting startups in London over LinkedIn Live. Now, so today we have Khalid, the CSO of Sensat. Khalid, thank you so much for being here on Construction
Hi.
Week. Could you kind of highlight what you guys are up to at Sensat?
Yes, absolutely. Oh, thanks very much for having me. It's always a pleasure talking about Sensat as soon as I get the opportunity. Well, Sensat, we're predominantly a SaaS company, and there's been an evolution since 2017 when we actually started off an idea, and that was basically to digitize the physical world that's out there.
Yeah.
And that was the whole overarching umbrella idea. There've been many attempts in the geospatial world to create digital sort of replicas or similar data provision, but just thinking about what the digitizing the physical world really means was an absolutely amazing brainstorming sessions in those days when we had. So that's the idea that we actually started thinking about. And then we decided that, the digital technology was evolving, the digital data capture was like, really fun days about in 2017, drones coming in. And then we sort of targeted the AEC industry, more and more towards infrastructure and construction. And we decided that mapping and surveying is probably one of the oldest professions out there and hasn't really changed much over the past decades or centuries. The equipment has, but so we thought we will take a new innovative sort of idea or innovative thinking towards mapping the whole world in very high resolution 3D, and that's where it all began. So we started targeting rail, road, estate, energy, utilities, all those sort of sectors within that industry. But the idea truly was that let's digitize this world. Let's see how computers can actually help us understand this world, because individually, as even experts, we have a very narrow sort of focus to certain things, and computers will be able to tell us. In those days, drones were relatively new. We picked them up, and we thought, when we saw the first data sets coming in, we thought, this is it. This is going to change things. It was such a rapid data collection sort of environment. And then we started putting a platform around it. So a web-based or a cloud-based platform that would allow visualization of such large amount of data. So Sensat basically became sort of a data capture company that digitizes the world in sort of a high 3D resolution.
I mean, why was like drone data a better option over other data capture methods?
It's because the other capture methods were either terrestrial, so you go out to the field and capture the data that you want to. Some of the data sets that were existing in digital form were based on old maps and slightly unreliable. Then the more sort of modern sort of tech that was coming in was satellite-based or aerial imagery. And I know that aerial imagery was extremely expensive. Satellite data, there was a lot of good publicly available satellite data as well. But again, the repeatability and then the flexibility to capture your own site was always an issue. Drones allowed us to just go, okay, let's just go fly over that site. Let's find out what the regulations allow us to do. And then the capture became rapid. And we could see the site that we actually had flown with some photogrammetry and some other processing within hours. We could see the site in 3D and in high resolution 2D, which satellites couldn't do. Aerial surveys took too long or were very expensive. So drones came in and completely disrupted that data capture.
That's incredible. I mean, can the technology be accessed in real time? And can you possibly talk about how the technology works in a practical sense? So possibly how a site manager, surveyor would leverage your technology, and what kind of insights that would enable and empower them to kind of capture and use in real time.
Yeah. So at the moment, most of our drone data capture is what I would call semi-autonomous.
Okay.
So some say it's fully autonomous because you just press a button and the drone goes away, and then you do
Yeah.
But in my mind, fully autonomous is slightly far-fetched. But I'll talk about a workflow of how we actually capture data, and then eventually how some of the users and the clients actually use it, and where the real-time stuff comes in. So we will identify a site to monitor. We will send out a team. The team normally plans a flight path for the drone. And these drones are quite large and fixed wings, not the traditional sort of DJI ones. But we do use those as well for certain reasons. But most of the time, it's fixed wings. Go into the field. We literally press a button. The computer basically takes over the drone. The drone goes up there and then does its things, takes loads of photographs. So that's pretty like autonomous on its own. Brings back the data. We process the data using certain algorithms, and it will throw out a beautiful 3D replica of your site. And then with drones, you can capture a very large area as well, at a very sort of small period of time. And then you start to get sort of traditional sort of geospatial data, which is like a very high resolution image of the area, just like Google Maps, but even higher resolution, around 2 centimeters. Even you can go higher resolution if you want to, but that's the sort of area that sort of work with. And digital surface models, the elevation sort of changes in the area, but the most visually rich data set is the 3D models that actually come out of it. Very granular, very, very detailed 3D models that you can actually see. So we then take that data set, we sort of put it into our visualization platform that Sensat's built, and specially designed to consume gigabytes and gigabytes. Each data set could be like 20, 30 gigabytes, and you have to deploy over the internet. So we especially design our algorithms to deploy that information very, very intelligently, so it's speedy. And then we put it in the platform and we give it to the client. And then suddenly clients, they have whatever there might be. I've taken an example for construction side. Suddenly they can actually see exactly what their construction site looks like in a holistic environment, not just like a Google Map view, but actually in 3D. They can go closer to certain assets, start to inspect those certain assets, but also with repetitive scans, which is quite easy to do with drones because you can just fly whenever you want to. But with, they can see the progress of their construction site happening. They can see earthworks moving around. They can quantitatively measure exactly how much soil has been moved around over a period of time, right?
Oh, wow.
But then we also then bring in the design work. So this is also something CAD and GIS, sort of separation that a CAD normally represents. A design work that what they want their site to look like eventually. And then the GIS and the drone data will tell them exactly what their site is. So then you have these two baselines, and then you just go, oh, this is how my site is progressing, this is where it needs to be, and this is how far it is, and how much more work we need to do. So the progress monitoring is a very, very powerful sort of, usage of the platform. And then you can start to implement sort of a sensor-based technology on their site. And that's how to bring in the real-time data set. So they can monitor noise, to look at the regulations that then they need to meet. They look at pollution, so whatever sensors. I mean, it doesn't really matter what sensors data sets are coming, because pretty much everything you put out into the site, it becomes geospatial. And suddenly the data starts to feed in, and then our environment can consume. And then so it starts off from what we call data gurus that are sort of people, users that are pretty much focused on capturing data or manipulating data and then using the data to capture the insights, to the site engineers, to even project managers that can eventually see the overall picture, but not just a a report or a PDF, but you actually visually can see. You can visually tag certain areas and then notify and collaborate with people to say that, look, this area is lacking progress. That crane has been sitting there for a while. Can you speed up the progress on that side? Or that stockpile is not depleting, so on and so forth. So there's a lot of, suddenly you have this hugely visually rich, exact replica of your site in a digital environment and online where you can access it from anywhere. And you can start to collaborate on it as teams, and something that's been missing in construction industry for a very long period of time.
Yeah.
And then we're trying to bring in that single source of truth in one place so everybody can actually come together.
That's incredible. So like a site manager can actually see a real-time view of their construction site and see what areas need to be improved, etc. And also what's amazing about this technology is, I think, the fact that it gives real-time insights and really new data capture. You're able to pick up on mistakes or potential banana skins, so to speak, that a normal human may miss out on. And in terms of measurement, how accurate is it to the millimeter or the centimeter?
Yes, that's a very good question, because one of the things that we always, I come from an academic background in the geospatial world, and then measuring accuracy has always been like, you publish and you have to sort of have measuring accuracy. But also the most important thing around accuracy is that it builds trust. Because so what we capture at the moment, again, we can shift our accuracies depending on sort of what we want to, but we can, with drones, drones and traditional photogrammetry, which is like taking photographs and turning them into 3D. We can sort of capture in around 50 millimeters in X and Y and 70 in Z. But then you go down to LiDAR data set, and then you decrease your flying height, and you can improve that accuracy. So, but it's a compromise. What the clients really want, how much of an area they want to cover, and how quickly want their data.
Yeah.
So it's a bit like what I say is that you go closer to the ground, the more accurate you get. Right?
Yeah.
So you can get a surveyor out, and that will be the most accurate measurement of that particular absolute asset. Right. But then you take a drone to that asset, and then you come closer and closer, the more accurate it's going to get. You can actually, with the technology, get millimeter accuracies, but then you lose the power of capturing a large amount of data set, because the closer you're flying to the ground, then the more you have to fly. So it's always a compromise, but we, on average, we sort of will give out sort of data sets with sort of 50 mil accuracy.
That's incredible. So you guys have drones that feed into a product called Maps, right? Yeah, and is it just outside you guys are capturing, or can you guys theoretically get a scanner inside of the construction site and to measure all the measure everything you need to inside?
Yes, absolutely. Look, drones started our story at Sensat because it allowed us to capture data. But drones are not the only thing that we do. We capture sort of aerial LiDAR. We have internal scans of buildings. Inside, the first internal scan that we ever did for our software platform was our old office that we actually were trying to get into. So we thought we're going to go in there, and then we actually used so that particular 3D point cloud and 3D model of the internal office to plan our furniture in there. How are you going to go in? That's the early days of startups, right? You build your own furniture. But no, absolutely, you can capture any type of geospatial data, be it terrestrial laser scans or aerial laser scans, satellite imagery. We can actually sort of deploy all of those. Obviously, not our own satellites yet.
Yeah. I mean, you mentioned digital twins. Could you simplify the concept and kind of highlight what it is? And then also later on, kind of tell us about what you can do with the digital twin. Is it possible to stress test a certain scenario for your clients? I don't know.
Oh, yeah. So now you're opening the box of Pandora here. Digital twin, the buzzword. I'm pretty sure that we're going to talk about another one, the AI that will come in. the digital twin, it's again a concept around so taking a physical environment, and trying to replicate in a computable world, right? Digital world in computers. And then the only reason we do that is that it's easy to compute and simulate certain environments that we can't do quick enough in the physical world, right? So digital twin, in just a very simple word, is just taking anything that is physical, living or non-living, and just trying to create a digital replica of it as close to as the physical world and its behavior, and then trying to understand exactly, or asking computers, or can you tell me how this really works? I know how it works, but because computers can actually compute much more faster. So that's the whole idea of the digital twin in general. But when you think about the physical world that we actually live in, the environment is such a complex environment, right? We've been trying to crack the understanding of this environment while breaking it, I'm afraid, this whole climate change and then, the anthropogenic issues. We've been trying to do that with expert knowledge in academia and in the industry for centuries, trying to save the world, as we say, and somehow we failed. We're not really saving the world, and you can start to see the evidence of it. So the whole idea of bringing digital twins in the physical to understand the physical world is that the potential is huge, that you can first, to start off with, have to represent that physical nature of that environment in computers. Second, you've got to make the computers understand what that physical environment actually represents. As humans are very good at learning. Computers are not so good at learning. Computers are very good at telling us what we want them to tell us. So while we can actually look at an object or look at an environment and understand its complexity quite well, for example, an urban environment, we know what houses are. We look at a particular area and we know it's residential, it's commercial. Computers don't know that. So for computers, it's just a bunch of numbers and points and polygons and, images. So although we can actually capture the data, try to create this digital world that visually looks like what we actually have in the physical environment, the next big thing in the digital twins sort of evolution is to make those computers understand what that environment actually is composed of. And by understanding, not just knowing, oh, that's a house or that's a road, but how they interact with each other. What is the whole topological relationship between people in that environment, or cars in that environment, or pollution, or the wind moving and weather and everything. You can see that it's a complex environment. Potential, once computers understand what the physical world and its composition of processes really are, computers have the power to understand the complex relationships that humans find so difficult. We can understand some simple relationships right in our faces, and they can give us answers. So simulations, yes, you could simulate a flood if it's going to happen or not. We've done that before, right? But in its isolation, in a digital twin, you'll be able to simulate a flood and then start to see how it affects everything else around it. The traffic, the people, the public transport, or even pollution, social demographics. And then the fun part comes in, that once the computers understand that digital twin of the physical world, we can replicate certain scenarios which we would like to happen. So, we do policies and we do regulations, and we said, okay, no, we've got to shut down the cars in London to stop pollution happening. We can actually simulate that environment in a digital twin and see and fast forward and then see exactly what the output might be. So we can actually play around with that physical world or replica of it without breaking it. So the decision making will absolutely change once this whole concept of digital world twins really kicks in. the true form of it. But at this particular stage, the digital twins are that let's try to replicate that physical environment as accurately as possible, because that's not even happened yet. And then while that's happening and we're capturing the data quite regularly as well, because physical environments update themselves very regularly and digital environments don't.
Yeah.
So while that's happening, we'll build the understanding for computers to happen.
Well, what are the core challenges of building and defining the real world, and how is that challenge reflected in a technology like AI?
Yes, there it is. Look, AI, it's a huge challenge. So in the past, I mean, I've been sort of working with sort of machine learning algorithms and then the concept of AI when it wasn't called machine learning.
Yeah.
Old days of perceptrons and neural nets didn't work. But in the past few decades, the neural nets or the AI, the deep learning, that is another buzzword, it's really, really progressed. And it's helped us sort of identify some algorithms that can really automate quite a lot of manual, laborious processes, right? So, but that's it. It's the automation part. Now, AI is such a huge umbrella and a buzzword that everybody makes their own decision what AI really is. So I'm not going to go into sort of go and define it. We've only got some amount of time, but I can go and talk about the concept of AI. But the whole idea of AI is that it's bringing intelligence, right? At the moment, we're at data stage, possibly insights, some knowledge, but the intelligence is a completely different ballgame, right? To make people be able, or computers be able to become intelligent, it's a long way to go yet. But what in the past few years, what we've seen is that AI has the capability of looking at or searching for patterns within data that humans are unable to do or very slow to do, right? So, and that's what we're working on at the moment. But the algorithms are in a way that whatever you want to automate, be it computer vision, object recognition, like, you know, the autonomous vehicles are searching for a perfect solution for recognizing objects around them. The idea at the moment is that these algorithms, these AIs or machine learning, they are narrow in intelligence. So they can do one thing and that thing only. But I'll tell you, they'll do that one thing at a superhuman capability. You know, they can play chess, they can play, you know, Go, and they can recognize cars. But then the algorithm that is recognizing cars, if you ask it to say or do my flood prediction, it's not going to do that, right? It's very narrow in intelligence. While humans are also narrow, but we still have a wider intelligence span or wider sort of understanding of the object. So we make a decision based on loads of different sort of ideologies coming into our mind. I'm going to go to a certain place. I'm going to look at weather. I'm going to look at sort of, you know, the traffic. I'm going to find out if my plans are working, if my family is okay for me to go somewhere. You know, loads of different. But machine learning algorithms are very narrow at the moment. And then the whole aim is to generalize them. So for an algorithm to be able to make multiple types of decision is the key. And that's where the biggest sort of a challenge really is at the moment in trying AI to say, there's your physical replica of the digital twin in geospatial world, which is even a more complicated environment than just few numbers. And I said, now try to tell me everything, you know, try to simulate something.
Yeah.
So that's not going to happen for a while. And also that at the moment we're working with Oxford University, and we've been sort of from the start, Sensat always wanted to look at the digital world in 3D domain. So we wanted to sort of focus on geospatial in 3D because we've been working with 2D data sets. The world is not 2D, right?
Yeah.
So we thought, okay, well, look, object recognition, that's a machine learning and deep learning that works really well on 2D images, cats and dogs and cars and trees, works really well. Let's try it on 3D data set. It failed miserably, I had one single dimension added, and that's it. These, and then the type of data sets that we're capturing, high fidelity, high resolution, it just doesn't work. Even the best and the best of the algorithms are out there right now. They work in that academic sense, so on a small little data set, so a few meters by few meters, or a kilometer by kilometer, and probably you can very manually tweak the algorithm to get you the results for that data, but it doesn't work for every data,
Yeah.
And then especially when you have like large infrastructures like HS2, and you want to, let's say, you want to do an object recognition of all their assets and then automatically tag all their assets, these algorithms are not gonna, so they're not even yet ready to recognize in that 3D domain on a large sort of a geospatial environment, let alone bring in the intelligence behind it. So at the moment, what we're trying to do is that let's create multiple narrow intelligence, right?
Okay.
So one that can do something, one that can do something, and then trying to somehow allow them to talk to each other. If one can't do everything, let's just try to create a few of them. Let's focus currently on the automation that AI is absolutely amazing at, right now. And then I'll tell you, construction industry requires a lot of that automation. It's an old industry, and it really needs digitization.
I mean, what you're describing is almost like a jigsaw. Not one source of data can provide you with a complete truth. So, I mean, could you highlight the sources of data that you guys are capturing that feed into what you already have, that give you the granularity of the insights that you're able to provide your clients? And if relevant, I mean, how does that kind of feed into your product strategy, or your, how does that feed into your product strategy if relevant?
Yeah, so the data, again, it really depends on what the clients really want. Because what we're trying to do is we're trying to take a high level approach on our product strategy that look, we need to find out how to look simple. I just said, if I go back and then I'll come back in. Construction industry, it's one of the least digitized industry in the world. Like, it's old, it's high stakes in there, huge amount of money and budgets and time and a lot of resources that have been put towards serving people, right? So it needs to happen properly. But it's not digital enough to be able to, it's very laborious and there's a lot of players within it. So collaboration is very important. So the data is an enabler that allows these organizations to actually have a single source of truth of all the data they have. And that could be anything. I mean, we capture 3D point clouds, very high resolution 3D mesh models, orthomosaics, digital surface models. We have algorithms that can take a digital surface model and turn them into a terrain model automatically. CAD drawings, designs, IoT sensors, name it. I mean, the data is just a Lego brick, right? How we actually construct it together, it's very important. And the end of it is all about how the clients extract value from that data. We've been in geospatial industry, the platforms have existed that can allow you to bring all of that data together, right?
Yeah.
But it's always been CAD, GIS, and then there's that integration that's always been missing, right? And what we're trying to do is that for users, we're trying to take that expert knowledge out of this whole geospatial platform that we have. So, for GIS, you need to be an expert in some GIS software to use, or CAD softwares. So we try and take that out. We're saying, look, it doesn't really matter if it's what file format it comes in, what proprietary software it comes from. You just dump it in, and you'll be able to visualize your digital twin or digital replica as it is. Just do that. Then from there on, once the clients start to see their software sites in this world, they there's that aha moment, and I'm going, oh my God, this is what my site currently looks like yesterday, and this is what my design files are. Oh look, they match perfectly. Yes, you know.
Yeah.
And even that is an aha moment, which always been trying to bring the real world and trying to bring the future world, which is design world, together. So that's our product strategy, just trying to create at the moment, trying to create that sort of a common visualization environment, right? So data environment's been there, and for me, I always get really annoyed by common data environments that it becomes a data dump, like it becomes a hard drive for all that information to be dumped in there. Files, we need to move away from. I mean, forget about files. It's what's inside the data that really matters to the user.
Yeah.
Yeah. You take away all of that sort of a hard work of files and data formats and coordinate reference systems or whatever not. Just dump your data in there, visualize it, and start making decisions straight away on basis of that. So that's pretty much what currently our product strategy really is, that make sure that our users have the common visualization environment that they've never had before. You know, it doesn't really matter if their data sets are in files or sitting on servers or comes from proprietary or not, and they can keep their designs. Although we can consume the design files and CAD and GIS and stuff, we are not a design software. So they can use their design software for what it's really useful for. This is where it all comes together. You know, this is where you suddenly start to extract value, and not just for data people, but for site engineers, because they can do their, for example, health safety briefing every morning on this data, rather than printing out a Google Map and sort of putting post-it notes on it. Or even project managers that can see the progress, how it's actually working, you know? And also the amount of sort of contractors that get sort of a part of it and joint ventures. Sometimes a single data set gets captured multiple times by different contractors, and then they don't know which one's the new one, which one's the old one, which one's the perfect design, or which is the old design. Just bring them all in. Bring also, the most important, not just data, bring people in that environment as well. Yeah. And have a conversation, you know, about what needs to be done. And then that's pretty much, data is just an ingredient. It's the overall process actually is to extract value from that whole data environment, but taking the pain points away from data.
Yeah, I mean, the construction sector has kind of been very terrible at adopting technology. I mean, compared to many other sectors, I mean, have there been any resistance to the adoption of your technology? To me, it sounds like a no-brainer. Like there are many measurements that a human can't really do at the time scale at which you guys can provide. At the timescale at which you guys can provide it. So, I mean, to me, it's a no-brainer. But I mean, was there any resistance to adopting the technology at the beginning?
Yes, it still is.
Oh, really?
Yeah, absolutely. I think it's an old industry, and it's a very procedural industry. So they identify certain processes, and if they work, they stick onto it. And because it's a very high-stake industry, those processes are very difficult to disrupt or change because they just work eventually. But I'll tell you, I mean, construction, apart from being the least digitized industry, it's also one of the biggest polluters in the world. I mean, in UK, I think there was some weird, really horrible statistics that came out last year that 60% of the waste is created by construction industry in UK. I was like, what? Look, we're trying to save the world here. Everybody's talking about the environment. You know, we're trying to save the world here. The industry needs to change, and it is changing. I'll tell you, we wouldn't be here if there were not players out there in the construction industry that were willing to change or seeing the innovation in there, the productivity in there, the cost effectiveness, and the timely manner of delivery of projects, which doesn't happen or have not happened in the past. This sort of adaptation of technology will completely change that. But as you always know, that once something is so rigid and has been working for a very long period of time, it's difficult to sort of take that very heavy train and then try to change its course. It take time. The whole idea of startups is we'll just do it quicker, right?
Yeah.
So look, as Sensat, we have a huge role to play in sustainability. And that's what we were sort of, yes, the data came in, and then the data capture came in, and digital twins and AI, all fun. But the whole idea is that how can we take an industry and make it extremely sustainable? And hence, one of the reasons in the early days when we thought about construction was, let's change it. Let's play a role in making this world a better place. And then I think construction industry will change. There are very positive signs that are coming out at the moment that people start to see value. Originally, they didn't, but they started to see the value of what digital twins and digital capture of data and technology like AI can actually do. And you'll see a huge amount of startups in this construction tech world that suddenly start to appear. It's beautiful to see that it's happening.
I mean, in terms of the adoption, it almost seems like a trust issue, because the sector seems like an expertise-led type of sector. I mean, obviously, my whole family is based in the construction sector, so I mean, the unwillingness to adopt the technology is quite prevalent, because they all have a system that works, and the challenge almost appears to be building that trust and winning that trust at the beginning. It's an interesting problem.
Yeah, it's I think once somebody said to me that it's difficult to make friends in the construction industry. Once you make friends, then you're good. You're good for that period of time, but also it's very easy to break that friendship, and that comes down to the trust. The trust of the data we're capturing, the trust of the platform that we're giving them, the trust of the algorithms that are providing the insights and possibly helping them make decisions, and eventually will make decisions for them. So trust is absolutely essential to I mean, even from people like site engineers and data guru, they'll make and sort of they tag an asset, and they want to know exactly how accurate it is, right? It's a very pedantic industry, millimeters, here and there, and they don't like it. So trust is very important in that accuracy conversation that we originally had. And we make sure that is intact,
Yeah, I mean, in an uber optimistic world, 24 months from now, I mean, how do you anticipate your platform? I mean, how do you believe your platform would have matured, and I mean, how do you hope to empower your current client base from a product standpoint? Yeah.
Okay, so as I mentioned, that the first thing we want to do is what we're doing at the moment is just to bring that visual environment in place, so everything can just come in and perform extremely highly. But then the next step, it is what we've actually spoken about, the AI. It is about the automation. It's not about somebody making decisions on the site based on data, but the data and then the platform helping them make that decision, even eventually make the decisions for them. It is simple things like that what we've sort of seen, that we do repetitive site scans, like there's a construction site and we fly over it every week or every 2 weeks or every month, depending on the frequency. But the platform, as soon as a new scan comes in, it calculates the change and it provides a report, right? That's what we would like to sort of, have this as an end, as a report giving out to the site manager. Look, this is what changed in the past 1 week.
Yeah.
You don't have to go and measure it yourself.
Yeah.
It just happens. And this "it just happens" bit is what we want to happen more, because there's a lot of laborious work that happens again and again and again and again in every construction site. Like, it doesn't matter if it's a large linear infrastructure or a small little building being constructed somewhere, or a tunnel. There are processes and patterns appearing on that site that are quite common across. Let's just automate those processes. Let's take all that laborious work out. Once we take that laborious work out, you also remove human error from it, right?
Yeah.
And then eventually start to build trust over it. But what we want to do in the 24 months is our algorithms to be making those decisions. When we fly the the drones, or capture the terrestrial lidar, or people can bring in their sort of local authority data sets. Open source data sets are out there, but they don't, because look, in GIS, it's always been, oh, I can get all the data together, right?
Yeah.
Once the data's in, then I'm thinking, how am I going to do that? How am I going to do this, or how am I going to do that? So our idea, it's sort of really is to automate all of those things.
Wow.
Eventually, you bring in your data, and then things starts to just happen.
That's cool.
Obviously, it's extremely. It's not just the algorithm part. It's extremely important that we get really close to these construction clients and find out exactly what they want to be automated, what brings value to them. That's the most important thing. I can create an algorithm that could do fancy things, but eventually it doesn't really matter what user don't care if it's AI or somebody sort of manually doing things. They want value from it. If they want to monitor stockpile change, that's what they want. That's their end game. You automate that part. If they want to sort of collaborate in a particular environment, then just do that. So algorithms, data, a bit more of the understand for the computers to be able to understand that physical world. So it starts to help us make those decisions. Uber optimistic. I mean, this is the sort of realistic sort of world of automation. Uber optimistic. Look, multiple algorithms that could actually understand each other's outputs, right? Wow. So a stockpile change can actually recognize if a flood is going to happen on site, and then order a pump for the site manager to make sure the site doesn't stop.
Ah, interesting.
Collaboration. Simple thing if you think about it, but it's just quite complex to actually implement.
Very complex.
Saying that use case, we're not implementing that use case yet, but it's this type of thing. So multiple processes combining together to be able to make decisions.
That's incredible. I mean, so like initially you guys are currently in the process of augmenting intelligence and then empowering the decision makers to make the right decisions. Absolutely. Hopefully eventually you'll be able to provide the insights that make that decision a little bit easier, and then later on when you've got even more insights, the decisions are already being able to be made. Is that it?
Yes, I mean, think about the autonomous vehicle sort of problem, right?
Yeah,
it is a perfect problem to solve because it's so complex that you break it down into its individual components, and those individual components are solvable. Object recognition, solvable. Navigation, solvable. Avoiding accidents, solvable. Appropriate route finding, solvable. We've done that as well. You bring it all together, unsolvable. So yes, that's the aim that we're working towards. That it's the holistic environment that matters. I think it's about time that analysts and experts start thinking holistically. A social scientist can do social science very well, social demographics. A sort of flood management hydrographer, so if it can really understand the topography and then how the water is going to sort of flow through it. But those two have never really got together, right? The knowledge share between them is very difficult, if not impossible. Computers will be able to do that.
Yeah,
they will be able to understand the holistic nature of that physical world that we're trying to save, and they will be able to sort of allow us to understand exactly what gates get impacted.
You guys have a phenomenal amount of data that you're able to provide your clients. I mean, just about their sites contextually. I'm going to go a bit wacky now. So I know you're using your data to solve your current use case, aiding construction projects, but hypothetically speaking, how useful could this data be in many different industry verticals? Potentially insurance, maybe follow-up financing or additional financing for construction projects. I mean, have you guys, I know solving the problem that you're solving is pretty difficult right now, but this data must be super valuable for insurance companies, follow-up financiers of construction projects. I mean, you're more than welcome to reveal your next. You're more than welcome to reveal your plans. Even though you didn't intend to, but shine some light on that.
Yeah, look, again, yes, the data set that we capture. Look, I came from an academic background where data was sparse always. We relied on publicly available free data sets. As soon as I saw our data repository getting to this day, I've been with Sensat for 3 years, pretty much from the start. To this day, anytime a new data set comes in, I have to see it. It is so good. It's so valuable. Insurance, yes, absolutely. It will help. And then but it's not just the data. It's, again, I will repeat myself a little bit, but it's what they want to extract from it. So if they are looking at sort of overall sort of area hazards that they want to identify so they can actually do their sort of planning properly, yes, absolutely. If they would like to sort of mitigate risks from that, then yes, absolutely. Data is just, as I said, just that Lego. Whatever you want to build with it, it's absolutely up to you. And then obviously algorithms will play a part in it. Then the more generalized the algorithms get, they'll be able to do a stockpile monitoring. At the same time, will give you a risk sort of a portfolio for insurance. So yes, there's a lot of work going on in the industry, not just at Sensat at the moment. Obviously, we're quite sort of we're Series A, so we're growing as we're teenagers in the startup world. Yeah. So we have to focus on that one particular industry. Then eventually, we will sort of branch out into all of the possible sort of fun stuff that we can do. But it doesn't stop us sort of talking about it. It doesn't stop us sort of every now and then grabbing a coffee and say, what if the neural net could just generate a city plan for us based on the past stuff, 100 years of planning that's happened in London. Let's just create a new city. That's far-fetched. And look, as soon as you find fun in it, the applications just open up. And once time is right, the data sets, the algorithms will be valuable to many industries.
I mean, as we're closing up, we talked about the C word, COVID. I mean, as a company, I mean, how did you guys have to adapt, and how did it affect your business? I mean, firstly, can you kind of highlight, how you guys were forced to adapt, and then kind of highlight how it helped or aided or didn't help or aid your process?
Yeah. So COVID's been an interesting period, needless to say, weird. And look, it's like startups, one thing that they're good at is adaptability. We can change like that, One thing good at is identifying if something's going to work or not work. So adaptability wasn't a problem. I mean, as soon as the whole sort of thing around COVID started to come in, even before the government regulation started to come in, we started thinking about as a company to what we're going to do, how it's going to affect us. Sales team are having their own sort of brainstorming that if this thing goes the way we think it's going to go, then how they're going to actually change themselves. And then a company as well. We even had like a mini hackathon in the office, just the round of how we're going to communicate. Simple thing.
Yeah.
Where communication. Yeah, we can do that. But no, just let's identify exactly how our workflows are going to change, the daily environments of engineers and then the executive office and the leadership team and then sales and data team, how they're going to go out. So we planned it all. We sat down, we wrote it all down. And then obviously what we wrote down was just a general brain dump. And then it changed or evolved over a period of time. But we kept changing. If something didn't work, we just changed. Did it help us? Did it hinder us? A bit of both, Construction sites shut down. And suddenly there was this demand of the digital replicates, right? Site managers wanted to see what their sites were, and then they wanted to sort of share ideas and collaborate with people. Certainly our platform stuff, was the bit. Our flights never stopped, so even the sites were shut, we will send out people, obviously they're perfect isolation environments, out in the open. And then they will capture the data, and suddenly the site manager has their data within days of the site. And so that was quite good. I mean, people interaction is very important in any startup, and culture is very important in Sensat especially. We really value our culture and the fun we have. Suddenly, everybody's gone online and go, oh, what's going to happen to our Friday quiz? What's gonna happen with all the other bits? But we never stopped. I mean, every day we're online constantly from one place to another place. We still have quizzes. We still have fitness sort of programs at lunchtime. So the culture is still intact. So it's sort of, look, I'll tell you that it was weird. It was difficult to start off with, to even think about how we're going to sort of cope with it. But we've become more productive about it. You know, we've learned as a startup that you allow people flexibility to deliver in their own time, and they deliver way beyond than what they originally expected. So it's again bringing the trust part. So COVID did allow us to sort of grow up as a startup, and then we started to become more productive about it within teams, and then communication like this is extremely important when you're brainstorming and whiteboarding sessions. That also allowed us to mature a little bit in our communicating ways that we've got to change. And now when we go into like a physical environment, we have been to the office a couple of times and then we've done the whiteboarding sessions. They are so productive now rather than going off the thing, because we know how to utilize that. So it's been good in many ways, but construction industry is also sort of benefit from our solutions. So yes, we've recruited quite a lot during this period as well. So that's a weird thing as well. Onboarding and working with people that you've never physically met before, and then you suddenly meet them after 3 months, and you go, "Oh, I know you, but I don't know you." So it's been a good experience.
Yeah, that's incredible. Yeah, I mean, final question. I mean, what have been like some of your toughest challenges as a CSO of Sensat? I mean, and how do your challenges differ from the beginning to now? Because right now you guys are quite healthy, you know, very well fed with your latest round of funding. You know, what were the challenges? How do the challenges differ from right now compared to a couple of years back?
Yeah, so when I joined Sensat, I could count the number of people in one hand. Now we're 50. I still every day try to remember everybody's name and know that I've got to remember whoever it is. But look, it's a huge evolution process that we've gone through in the past 3 years, and the challenges are completely different. They change very rapidly. So earlier on, I mean, I remember having a brainstorming session in early days. That, how are we going to take 1 million points in a point cloud and deploy it onto a web-based environment in 3D? How are we going to do that? What sort of algorithm is going to be able to do that rapidly? Early days. Now our platform is consuming billions and billions of points. No problem, right? So that problem. So you see the challenges change as well in technology. So early days, it was very much focused on technology, data, because we were really excited about the data. Now we're very much focused on the users. Fine, we've got the data. Let's find the value for the users, because that's the most important thing. So yes, the challenges are changing. For me, as a CSO, or I would like to call it the chief scientist. I think it's a better title, right? Can't have a better title than that. But I try to, so it's a fine balance between looking at what is required right now in terms of the data science, in terms of the AI, in terms of geospatial. So I sort of pretty much spread around all data teams and engineering teams, and then trying to bring value as soon as possible, as quickly as possible, back to the client. But also, what's next? What's that 24-month looks like? Is there some of our technology right now that's embedded and working fine? Is that going to break in 24 months? So as a chief scientist, I have to sort of think ahead a little bit as well. And then start to sort of proof of concept and experiment. And that's the fun part. Trust me. You start to experiment things that you don't know if it's going to work or not. And look, I was given an advice in early days by a very experienced of a technology manager. And he said, look, one thing that he always worried about Sensat in those days was that it's such a great idea. It's such a great execution at that time as well, that you guys are not going to know, or you guys are not going to fail quick enough.
Interesting.
And that was, it stuck with me, you know? So I am very, very sort of every day pretty much thinking that, is this the right thing to do, right? Question yourself every single day. You know, you're working with your OKRs or KPIs, question them every week. You know, if you've made a mistake, change it very quickly. So I'm very conscious that we're working with such fun projects and fun data that we'll carry on doing whatever we're doing, and then eventually realize, oops, that was not the right thing, and it's too late. So we've got to keep an eye out. At the same time, again, one of my colleague gave an example that it's like swimming. You know, you put your head down, you get your things done, and then every now and then you look up and look ahead where your destination really is. And that's very important to keep looking at and realigning yourself. So it's a lot of good fun science part, looking at loads of different sort of algorithms that our academics are still producing that don't work, still publishing, still working with academia, and a lot of engineering. Yes, great job.
I mean, just given the amount of data you guys have, I mean, sometimes are you guys always questioning what products to build and what products? What products to build, and then what products will unlock value very quickly for your clients? Is that kind of is that the type of decision making framework that goes on in your head
every day, every day? So we sort of, you know, as most of them work, we work on quarterly basis, but our objectives and KPIs, they change very, very rapidly. You know, sometimes monthly basis, sometimes quarterly basis, but we're not scared of changing our the ways that what we think is the right way. There's an assumption from the data geeks and the data scientists that, oh, this will be really value.
Yeah,
absolutely essential that you get close to the client, find out from the user if it's really value or not.
Interesting. Well, I mean, this has been a fascinating conversation. I really appreciate you jumping on. For people that want to get in contact, or construction site managers, construction companies want to get in contact, how do they find you guys? And are you guys hiring?
Yes, absolutely. We're sort of we're Series A company, so we're sort of in the mid of it. We're planning for the next round. And COVID hasn't stopped us. We're still working hard, so we need sort of people. So yes, if you go to sensat.co.uk, you'll find a lot more information about us. You can find some case studies that we actually worked on. So you know, big clients that we've actually worked on: Heathrow, HS2. We've just become part of the HS2 innovation scheme, which is absolutely exciting stuff. So yeah, a lot of good fun is happening at the company, and then the jobs are also advertised. We're recruiting in software engineering and data and sales. So yeah, go to sensat.co.uk and then find out. And there's some fun videos there as well, especially on our YouTube channel.
I really appreciate you jumping on today. Thank you so much.
It was a pleasure, Sheikh. It was a pleasure.